Hello my class 10 students. Here I have physics ICSE class 10 semester 2 board paper, that is section B, answer key, and also this video will help you to calculate your ICSE physics board score, as I have been ICSE examiner for physics in the past. Do watch this video till the end, and if you find it helpful, consider subscribing. Okay, the section A answer key is already uploaded. The link will be somewhere here, and now we start with section B. Okay, so our section B has question 2 to question 6, which means 2, 3, 4, 5, 6. There are 5 questions. Out of these 5 questions, you have to choose any 3 questions. The 3 questions will have 10 marks each. So section B is going to give you 30 marks. Alright, so now that we've understood this, look at our question 2. The first part, the diagram below shows magnetic compass kept closer to the coil AB, wound around hollow cylindrical cardboard. So we have this cardboard and this is the coil, and you have to find out, after studying the circuit and the magnetic compass carefully, state whether S1 is open or closed. So this switch S1, we do not know if it is open or closed. But supposing if it is closed, then the current will flow like so. And here it will be clockwise direction, and so A will become south. Now the key over here is this magnetic compass. The magnetic compass, the Earth's magnetic field should have the magnetic compass like so, which means this is north. So the north of the key should point here, upward. But the north is pointing downwards, which means this north of this magnetic compass has got attracted to this south, which is the polarity formed at A. Now, if this has already shown the deflection from vertically upwards to vertically downwards, can you see that? It was vertically upwards because of this, but now it is vertically downwards like this, means it has got attracted to this, which means A has already become south pole, which means the current is flowing through the circuit, which means if the switch was open, there would be no current here and there will be no polarity, and magnetic compass would still have shown this. Got that? So let us see how we write it. How did you arrive at the conclusion in A? And what is the purpose of placing the magnetic compass needle in this above setup? And this is a 3-mark question. So let us see how we write it. So in the answer paper, we'll write section B, we'll write question 2. If we are attempting this, remember we have to attempt any 3 questions. And A answer will be whether it is closed or open. It is closed, and that will give you your 1 mark. As the magnetic compass needle, according to the Earth's magnetic field, would be in this position, that is showing north. But in the diagram, the compass needle is like this, which means north is pointing downwards, indicating that A of the solenoid has already acquired south polarity. Now this is possible only if the current is flowing through the coil. That means the switch S1 is closed. So we'll give you your 1 mark. And what was the significance of the magnetic compass in this setup? It helped to determine if AB had acquired magnetic property as a result of electric current flowing through it. That means it helped us to determine if the switch was open or closed. Without that compass, it would have been difficult. So that will give us a 1 mark. Yes, the explanation is a little longer, but then you can't help it. It is the correct and accurate explanation. Let's come to the second part. Let's see the question. The second part, give an important reason for copper to be used as the material of the calorimeter. Calculate the thermal capacity of 40 grams of water when the specific heat capacity of water is given as 4200 joule per kg per degree C. So let us see how we write this. Now you will see how to present your work for the board paper. So for the next few papers that are remaining, you can use the format that I'm using here to present the answers. Copper is used as the material for calorimeter, as copper is a good conductor of heat, so quickly absorbs heat from the contents. And the second part you have to mention is that it has a low specific heat capacity. So because of small c, remember capital C dash, that is heat capacity, is m into c. This also becomes less. So it lowers the heat capacity, and so the calorimeter takes a negligible amount of heat from its contents to acquire the temperature of its contents. And this will be point number 1, this will be point number 2, so this will be 2 mark. We don't have half mark, so it will not be 1.5 and 1.5 here. Trust me, board doesn't give half marks. Now let us come to the B part. Mass was given as 40 gram, specific capacity of water was given in SI, and we have to find heat capacity. So heat capacity formula is m into c, as we saw here also, and m will be 40 upon 1000. Why did I divide by 1000? Because this is in gram and this is here in SI. So I have to make this into kg, and then you cancel the 0. 42 into 4, 168, and this kg and kg unit wise will get cancelled, and joule per degree C. So that is our correct answer, 168 joule per degree C, and that is our 1 mark. Let us come to the third subpart of question 2. We have a circuit diagram here, and from this circuit diagram we have to find the external resistance, which means you have to find this, which is Rp, and that Rp will be added to 2, and that will give us our first answer. The current I2, that is this one, when I1 has been given as 0.4 ampere, and the total current has to be found out. Let us see how we write this. So I've drawn this diagram and I've written over here external resistance. That will be our first question. So 12 and 8 ohm, they are in parallel. So we use this formula, 1 upon Rp is equal to 1 upon 12 plus 1 upon 8. And the LCM here is, oh, I used 48. I could have used 24 also. But you know why I did this? Because I'll get here 12 fours and 8 sixes, so I'll get 10. So I don't have to reduce this 10 upon 48. So Rp becomes 48 upon 10, that is 4.8. Okay, so if you had to take 24 as the LCM, you would have got 12 twos plus 8 threes. So you would have got 5 upon 24, which is this anyway. And then you will say Rp will be 24 upon 5, which is the same thing. Doesn't matter. As long as you get this, you will get your mark. So external resistance will be this 2 ohm plus this Rp, that is 2 plus 4.8, that is 6.8 ohm, and that is our first mark. For the second part, for the B part, I1 is given as 0.4 ampere. So I am saying let R1 be 12 ohm. Let's look at the diagram. If this is I1, then we'll call this as R1. This is I2, so we'll call this as R2. Now one method would be to find the potential difference across the parallel circuit, but the shortcut would be just to use I1 upon I2 will be equal to R2 upon R1, because your current is inversely proportional to resistance. Okay, so I1 will be 0.4 ampere, I2 we do not know, R2 is 8 and R1 is 12, and then we shall say I2, which comes here, and 8 upon 12 goes that side, so it becomes 12 upon 8. So 0.4, I'm writing 4 upon 10. This is 12 upon 8. So 2 ones and 2 sixes. So 6 upon 10 gives us 0.6. So that becomes our second mark. And the total current would be, look at the diagram. This I is split into I1 and I2. So I1 plus I2 must be equal to I. So it's that simple. I1 plus I2 means 0.4 plus 0.6, and that is 1 ampere, and that is our 1 more mark. So this question was for 3 marks. So if you got 10 on 10 for question 2, write in the comments. Let's go to question number 3. We have 3 wires with proper color coding. They are connected to the 3 terminals of the 3-pin socket. So this is your 3-pin socket. Match the color of the wire with the appropriate terminals A, B and C. Now you know that A is earth and this is a socket. So this becomes your live, this becomes your neutral, correct? Now brown means it is going to be live. So live means it is going to be C. Green is earth. So earth is going to be A. And the light blue is neutral and neutral will be B. So we have CAB as our answer. We will write it in the answer section. We'll come to the second part. Why does it become colder after the hailstorm than during or before the hailstorm? This is one, that is A part. And B part is if two bodies have same specific heat capacities, then they will always absorb the same amount of heat if the temperature increases by the same amount. So they are telling you that your Q1 will be equal to Q2 because C1 is equal to C2 and delta T1 is equal to delta T2. They are saying state whether the statement is true or false. Let us see how we write these answers. So answer 3, we have, as we have written over there, I have written this way. So this is going to be for your 3 marks, 1 mark each. And then we have the second part which talks about the hailstorm. After the hailstorm, it becomes cooler. The ice of the hailstones starts melting after the hailstorm, correct? And the specific latent heat of fusion of ice is huge, that is 336,000 joule per kg. It's better that you mention this. Thus each kg it's per kg, so each kg of hailstones, that is ice, at 0 degrees C absorbs a large amount of heat. How much? 336,000 joules to become 1 kg of water, and that will be at 0 degrees C without any rise in its temperature. Now this heat is absorbed from the surrounding. When it is absorbed from the surrounding, obviously the temperature will be lowered. So it will become colder than before or during the hailstorm. When, during or before the hailstorm, the latent heat is released into the surroundings, so it will be warmer. Okay, so this will be for 2 marks. All give reasons are 2 marks. So for writing this and then to write this part, that will be 1 mark and 1 mark. And the third part, whether you had to say the statement is false or true, that would be for 1 mark. Now I have written that it is false, and let us see the reason. The two bodies have the same specific heat capacities, like how I told you, C1 is equal to C2. So they will absorb the same amount of heat to raise the temperature. I have repeated this, raise the temperature of unit mass of each by 1 degree C. So 1 degree C means your delta T also is the same, correct? Now your SHC talks about the unit mass. What is our statement saying? That the statement is saying that it will have always the same amount of heat absorbed if C1 and C2 are equal and if delta T1 and delta T2 are equal. Did it mention anything about the mass? So in this statement there is no mass mentioned. Therefore, if their masses are different, then the heat absorbed by the greater mass will be greater even if the rise in temperature is the same. And you know this very well, Q is equal to mc delta T, correct? So your heat absorbed depends upon not just specific heat capacity, not just on delta T, that is change in temperature, it also depends upon the mass. More the mass, more will be the heat. Okay, so that is why it is false. Alright, let us come to question 3, third part. A metal piece of mass 420 grams at 80 degrees C is dropped into 80 grams of water present at 20 degrees C in a calorimeter of mass 84 gram. and the final temperature is 30 degrees C. Then calculate the specific heat capacity of the metal piece. Specific heat capacity of water is 4.2 joule per gram per degree C, and specific heat capacity of calorimeter is 200 joule per kg. Now everything is given in gram and this is given in kg. So you got to convert it into 200 upon 1000. So that becomes 0.2 joule per gram per degree C. So this is the tricky part, and this is for 4 marks. Let us see how these 4 marks can be obtained in full. To begin with, I like to make the columns like this: substance, mass, SHC, T1, T2, that is initial temperature, final temperature, and this is the delta T. We have the metal, the mass was given as 420 degrees C, it was at 80 degrees C. It was plunged into the water, which was 80 grams, and it was at initial temperature of 20 degrees C, and the water was in the calorimeter of mass 84 grams, and that was also with the same temperature, and the final temperature is 30 degrees C, which will be common to all of them. So delta T will be 80 minus 30, 50 degrees for metal. Here it will be 30 minus 20, that is 10 degrees C for water. And here again for calorimeter, it will be 10 degrees C. I have written over here, we have to find X, that is the specific heat capacity of metal, and water, the SHC is given like so, and calorimeter the way it has been given. This of course means it is 0.2 joule per gram per degree C. By the principle of calorimetry, at equilibrium, heat lost by the metal, because it is hotter at 80 degrees C, will be equal to heat gained by the water plus calorimeter. Okay, so to write this, it will be your first mark. Alright, then the correct substitution. Can you see the correct substitution? Can you see this step? This will be important. This will be for 2 marks. Okay, and then to calculate all this and getting this, that will be for 1 mark. Alright, here is where you have to be very careful. From here to get this, from here to get this, from here to get this. Okay, all that is including substitution would be for 2 marks. So you can actually say that this step would be 1 mark, this step would be 1 mark. So that is how we will have 4 marks distributed for this. Make sure that you write your units properly, and that gives us our 4 marks. This finishes question 3. Now question 3, whether you got 10 on 10 or whatever you have written, you can write in the description box. I hope all of you have got 10 on 10. Let's come to question 4. Rohit is playing a flute and Anita is playing piano, and they emit the sounds of same pitch, means frequencies are the same, and same loudness. So the amplitude also is the same. Name one characteristic that is different. That will be quality or timbre, yes. Now if the loudness of sound from the flute becomes 4 times the sound from the piano, then write the value of ratio AF is to AP if AF is the amplitude of sound wave from the flute and AP is the amplitude of sound wave from the piano. And then the third part says define pitch of a sound, and this is for 3 mark. So one characteristic, this will give you 1 mark, this is 1 mark, and this is 1 mark. So we write question 4. First part A is quality or timbre, so that will give us 1 mark. Now loudness of flute becomes 4 times loudness of the piano. So loudness of flute upon this goes this side, it goes in the denominator. Loudness of piano, that will be equal to 4, but I am writing 4 upon 1. Now do we know that loudness is directly proportional to amplitude square? So the loudness of flute will be amplitude, it will be proportional to amplitude of flute whole square, and the loudness of piano will be directly proportional to amplitude of piano whole square. So this 4 upon 1 becomes AF square upon AP square. So we will take the square root because we are expected to find AF upon AP. So square root of 4 upon 1 becomes 2 upon 1. but they ask you the ratio, so we have to write it like so. You cannot write like this. If you write it like this, you will have 1 mark less. In fact, the teacher can give you 0. Okay, so we write over here 2:1, and that is your 1 mark. The third part was to define what is pitch. Now pitch will be there in any textbook, correct? So I don't have to write it down, you have learned it, so that will be our 1 mark if you produce it exactly the same way as it is in the textbook. Question 4, second part. A. Name 2 factors on which the force experienced by a conductor carrying current placed in the magnetic field depends, and also state how these factors affect the force. Now remember, the force is equal to this, correct? You remember this? Force is equal to IBL. So force is directly proportional to I, directly proportional to B, and directly proportional to L. Let us see how we write that down. But also let us look at B part. With the help of which rule you can determine the direction of force acting on the current carrying conductor placed in the magnetic field. So here we have 3 quantities: the force, the current carrying conductor, the direction of the current, and the magnetic field. So that will be Fleming's left hand rule. So see how we write the answer. Force experienced by a conductor carrying current placed in a magnetic field is, number 1, directly proportional to the current, which means it increases with increases in current. If you don't write this part also is fine, but it must be mentioned directly proportional. Remember what I told you, F is equal to IBL, correct? So I was the current, so we wrote directly proportional to current. What is B? It's the magnetic field strength. So we say it's directly proportional to what? The strength of the magnetic field. That's how we need to check or double check our work. So strength of the magnetic field. So it increases with stronger magnetic field. Now supposing you made a mistake, like I have it's just slipped my mind, okay? I wrote magnetic current because I was carried away. I wrote instead of field, I wrote current. But can you see it increases with stronger magnetic field? This will give me my mark. Okay, so this will be for 1 mark this, 1 mark this, and Fleming's left hand rule, that will be 1 mark. No need to write the whole rule. Question for third part. What is nuclear energy? This again is a definition you can take from the textbook. Let us look at B. After emission of a nuclear radiation, the atomic number of the daughter nucleus increases by 1. Now when it increases by 1, the atomic number, then it is beta radiation, yes? Now C part says, write the nuclear reaction indicating the nuclear change mentioned in B, that is this. And then what is the special name given to the parent and daughter nucleus when this radiation is emitted? Let us see how we write it. So A is nuclear energy. As I told you, you can refer to your textbook, so you will come to know whether you got it right or not. So that will be 1 mark. B says that if the atomic number is increased by 1, it will be which radiation? So beta radiation. That will give us again 1 mark. And the nuclear change. So if I write X, A, Z with beta radiation, beta particle, that is 0, E minus 1, that is your beta particle is given out. So your X will become another element Y, which will have A remaining the same and Z becoming Z plus 1, correct? Why did that happen? Because 1 neutron has become 1 proton plus 1 electron. So this electron from the nucleus was thrown out, and that is this. Alright, so the number of protons has increased by 1, so Z became Z plus 1. So writing this is 1 mark. Now you will say, should we write this, should we not? It's better to write, it impresses your examiner. So examiner knows that you are thorough. Okay, come to D. The parent and the daughter nucleus formed when beta radiation is emitted, they are isobars. So why are they isobars? Because the mass numbers are the same and the atomic numbers are different. So this is the term isobar for the nuclei like this. Okay, question number 5. Now, as of now, we have finished solving question 2, 3 and 4. Okay, so that should give us actually the 30 marks, but of course there is a choice. So I'm now solving the question number 5 and question number 6. You could choose any one of these. Okay, if you chosen question number 5, then you should know what would be the marking scheme and how to score your full marks. An appliance is rated 440 watt and 220 volt and it is connected to 220 volt. So calculate the maximum current the appliance can draw and the resistance of the appliance, and this is for 3 marks. So we write the power 440, PD is 220. The maximum current the appliance can draw, that will be I equal to P upon V. Now if you don't remember this, please write the formula of P and V and I. How are they connected? P is equal to VI. So I will be equal to, V comes here, it becomes P upon Vs. So we substitute and get the answer, that is your 2 ampere. Okay, so this is your answer 1. So this is for 1 mark. Then we have to find the resistance of the appliance, which means I have to connect P, V and R. So if you don't remember this, right over there, the relation with P, V and R, that is P is equal to V square upon R. So R will be equal to, R comes here and P goes there. So it becomes V square upon P, yes. So after substitution, you will have here 1 0 getting cancelled, 22 once and 22 twice. And 2 once and 2 goes here once and 0 times. So that will be 110 ohm. So that will be for 1 mark. Okay. Now this question is for 3 marks. So 1 mark will be for this, 1 mark will be for this, and overall the examiner will see whether you written the formulas properly or no and gift you the 3rd mark. Question 5, second part. The diagram below shows the vibrating tuning fork E. It is mounted on a sound box X. When a vibrating tuning forks A, B, C, D are placed on the sound box Y, one by one, it is observed that the loud sound is produced when the tuning fork B is placed on this. So if there is B placed here, then there is loud sound, which means the frequency of E and B must be the same. What is the frequency of B? 320 Hertz. So what will be the frequency of E? It will be 320. Why is B producing louder sound? Let us see how we write it. Second subpart, A. Frequency of E will be the same as frequency of B, that is 320 Hertz. So that is your 1 mark. Okay. Then B is telling you, write why the loud sound is produced by B. Because both E and B, they have the same frequency. And when the frequency of the external periodic force, that is E, equals the natural frequency of vibration of B, then due to resonance, can you see how I'm underlining the keywords? B will vibrate with a larger amplitude and will produce louder sound. Okay, so here we'll say they have same frequency and the resonance and larger amplitude, that would be your 3rd point. So we have this for 3 marks. We come to the 3rd subpart. From the graph of heating curve given below, state the melting point and the boiling point of the substance. Now remember, this is a flat curve over here and there's another flat curve over here. So this would be for boiling and this would be for melting. Okay. Now what is this temperature? It is 40 degrees C and this is 80, 120, 160. Can you see that? Okay. And then we come to B part. Complete and rewrite the following nuclear reaction by filling in the blanks. This is the one. Let us see how we write it down. This is for 4 marks. So 2 marks for this and 2 marks for this. Let's see the solution. So we say melting point is 40 degrees C. This is 160 degrees C. That gives us our 2 marks. Now here there are two blanks, so we call this as A and this as B. Now take the top line, that is mass number, it is conserved. So 235 will be equal to B plus 4. Can you see that? Yes. And the bottom line over here is the atomic number conserved. So A is equal to 90 plus 2, that is 92. Yes. But they say rewrite this. So we rewrite this with this A and this B. And we write this properly. And that would be for your 2 marks. 1 mark for this and 1 mark for this written properly. Okay. Now you will say, what will happen if you just do this? Well, they told you to rewrite. Why don't you rewrite as the question tells? If you write this, then you have to be at the mercy of the examiner. You literally have to beg and plead, please give me mark. But if you read the examiner's instructions well, then you should get your full marks. So up to here, if you stick to the instructions of the examiner, you should not get mark. If you write this, you should get marks. Full 2. 1 for this and 1 for this. Okay. Now some of you will say that we did this mentally and we wrote this. No problem. You'll still get your 2 marks. Okay. But this is just for your understanding. Let's come to the last question. Question 6. We have been given this graph and you know what this is. This question has been repeated so often. This is your damped vibration. Study the above figure and answer the following. What type of vibration does it represent? Damped vibration. State one reason why the amplitude decreases with time and write an example of natural vibration. Let us see how we write the answer. So we have question number 6. We have A, which is damped vibration, that will be for 1 mark. Why is the amplitude decreasing with time? The energy of the vibrating particle is constantly decreasing. Why? In doing work against what? The force of friction offered by what? The surrounding medium. If there is no surrounding medium, it will not have to do that work against the force of friction. So this decreases the amplitude continuously and with time. Okay, so to write this whole thing properly is 1 mark. Example of natural vibration. Write a typical example like a tuning fork vibrating in vacuum. This is important because then you will have the natural vibration where the amplitude with time remains constant, and that will be your 1 mark. Question 6, second part. A certain beam of alpha particles, beta particles, gamma radiations travel through a region of electric field produced between 2 oppositely charged parallel plates. There is A and B. They are oppositely charged. Which of the above 3 has maximum speed? Now you know maximum speed will be gamma. Yes. Which one deviates the most from the original path? The lightest particle. Which one? Correct. Which one does not deviate at all when passing through the region of electric or magnetic field? Again, that will be gamma. Okay. Then we have the third part. If the wire of resistance 2 ohms gets stretched to thrice the original length, calculate the new resistance of the wire and what happens to the specific resistance of the wire. This is for 4 marks. So this will be for 1 mark and this will have to be for 3 marks. Okay. Let us see a solution. So whenever I have a comparison like this, when the wire is stretched to 3 times the original, I like to make the 2 columns. So we have R1 2 ohm and we have to find R2, that is the new resistance. If L1 is L, after stretching to 3 times the original, it becomes 3L. A1 is A. So after stretching, A2 becomes 1/3 of the original, that is A by 3. We know that R is equal to rho into L upon A. And so R1 upon R2 would be L1 upon L2 because directly proportional to the length, and A2 upon A1, that is inversely proportional to the area of cross section. Okay, so we substitute 2 ohm upon R2 and L1 is L, L2 is 3L, A2 is A upon 3, can you see that? And divided by A1 means divide by A. So L and L gets cancelled, A and A gets cancelled. So we have 3 3s 9, 9 into 2 is 18 and R2 multiplies here. So that will be R2 equal to 18 ohm. So to get this you will have 1 mark. Now remember it's a 3 mark question. So to substitute correctly would be 1 mark, and to get all this part, that will be for 1 mark. Okay. The B part, the specific resistance of the wire, what happens to it? It will remain the same because it's the resistance of the unit length. Whether you stretch it or whatever, the unit length and unit area of cross section, resistance of that remains the same. So that would be for 1 mark. Alright, so I hope you have understood what it takes to have full marks, how the marking is done, how to score your marks in your physics ICSE semester 2 examination. I hope you have found this video helpful. If you found it helpful, consider subscribing and sharing it to your friends. Okay, so I'm ending this video over here. All the best for your remaining papers, and keep looking out for the chemistry papers, sample papers that I will be uploading very soon. And also after the chemistry paper, I will upload the solutions. In the meantime, study well, study hard. All the best for your exams. Bye.